Hello. By now you have done a lot of factoring and you've become an expert on factoring, right? One of my students was just asking me, like, what are the applications of this factoring? Well, there are so many applications. As you move on to the chapters like quadratic equation and all, each and every problem will involve factoring, okay? Let me remind you of some cases which we have already seen, right? Now here is one. How can factoring help to find product of 39 and 41? Well, it can really help you to find any product. For example, we have taken 39 and 41 in this case. Well, this is a simple example to explain, so good values to take. 39 and 41. So what we are trying to find out is what is 39 times 41. This is what we want to find. Now, as such, it could be very complicated, right? But I can write 39 as what? 40 minus 1. Think like this. 39 is 40 minus 1. And what is 41? 41 is 40 plus 1. You see that? Now, that makes very simple numbers. 40 and 1 are simpler than 39 and 41, correct? Especially when you need to find products, right? Now, this is like a plus b times a minus b, or a minus b times a plus b. You remember what it is? It is a square minus b square, correct? So this is 40 square minus 1 square. I know 40 square, okay, 40 times 40. So 4 times 4 is 16 and 10 is 100. Is it okay? Minus 1 times 1 is 1. So you get your answer right there. And what is your answer? 1 less than 1600. So let me write this as 1599, right? So that's my answer. So you get such a good answer in no time without really taking help from the calculator, right? So this is a very good application of factoring. Let me remind you for the second. So I've taken this question here as determine domain of a rational function, and here is some rational function. Now in general, how will you find domain of a rational function? You know, rational functions is x belongs to all real numbers except restrictions. You remember? Now, how do you get the restrictions? Restrictions you get by equating denominator to 0, because denominator cannot be 0 since you cannot divide by 0, correct? That is why. So, how will you find denominator value, x value, for denominator which can make it 0? Factoring is the solution, correct? So let me write this Rx again as 2x minus 1 over, let me factor this out, x cubed minus 5x squared plus 4x. So I can take x common, right? So I'll write x and then I'm left with x squared minus 5x plus 4, correct? And this is equal to 2x minus 1 divided by x times, I can factor this, right? We are looking for a product of 4 and sum of minus 5. So the magic numbers are minus 4 and minus 1. When you multiply two negative numbers, you get plus, and when you add them, you get a bigger minus, right? So this could be written as x minus 4 times x minus 1. So that makes it, this Rx is equal to this. And now, what is the restriction? So we can write restriction as x is not equal to what? Equate each factor to 0, right? X equals to 0? Well, it cannot be, because then it will make whole thing as 0. X cannot be. X minus 4 equals to 0 gives x equals to 4, and this one x equals to 1. So these three numbers are excluded from our set of real numbers. Therefore, what is the domain? We say domain is equal to x belongs to real numbers where x is not equal to 0, 1 and 4. So this is a huge application of factoring. Do you see that? Now, let me take you to the word problems. Okay, now many kinds of word problems are asked. For example, if you throw a stone, How far will it land? Of course, you'll equate height or distance or something, whatever that parameter is, to 0 on one side and factor the other part, and you will get the answer. Okay, we'll do a similar kind here. Okay, now here the question is, the underside of a bridge is a parabolic arc defined by height as a function of distance as this, where ht is the height in meters above the bottom of the bridge, and d is the distance in meters from left side of the bridge. Let me make a small picture of this. Okay, it's something like this. Let's say this is our bridge. Now let's read it again. Now this is the function height with distance as a function of distance, and this is our distance. We say it is in meters. Okay, both are in meters. Let's write this is also in meters. Okay, now the equation is height hd equals to minus 0.5 d square plus 2.7. So okay, that's our function, right? hd equals to minus 0.1 d square plus 2.7 d. How wide is the bridge? That means we want to find how wide is this from here to here. That is the width of the bridge, right? And what are we given? Height. Now if the height is 0, you'll end up here or here. So we are looking for these 2 points where the height is 0. Okay, so let's do it. Easiest way is to factor this out, and when we factor, we can take minus 0.1 d outside. You see that? What are we left with? D, and minus we took, so this plus becomes minus, correct? And 2.7 divided by 0.1 gives you what? 27. Correct? Now height should be 0. That means 0 equals to this. Now when can this be 0? This can be 0. If this is 0, is it okay? Or this is 0, right? Then write equal to 0. So solve for it. So that gives us one result, d equals to 0. This is from here, right? And from here we can say d minus 27 equals to 0, or d equals to 27. So we got this point at 0, it looks like, and this says 27. So how wide is the bridge? So bridge is 27 meter wide. Does it make sense? So see how useful factoring is to solve our problems, correct? Now let's look into the part B of the problem. Okay, let me pull the paper up a bit and then let's solve part B of the problem. Here it says, how far from the bridge is the height? 5 meters. Kind of tricky. It means how far from the bridge is the height? 5 meters. So let's assume we are saying from the left side of the bridge. So let me write left side, okay? Left side of the bridge. It could be right or left, but let's go from here, okay? So let's say we don't know, and let's say this is 5, let us say, right? And we want to find this distance. How far from left side of a bridge do we have a height of 5 meters? So okay, so that means height is 5, so hd is 5. So let me write hd is 5 equals to the equation minus 0.1 d square plus 2.7 d. Is it okay? So the idea is to solve this equation, right? So we'll bring 5 on this side. So you get 0 equals to minus 0.1 d square plus 2.7 d minus 5. But there are too many decimals. Let's multiply each by 10, and 0 times 10 will be 0, correct? So this will be minus 10 times 0.1 will be 1. So just d square, and this will be plus 27d minus big number 50, 5 times 10. To solve this, we can use quadratic formula if you remember, or we'll use factoring because it's all about factoring now, right? Let's factor this out. Okay, when you get these kinds of terms, I prefer to write minus and factor it like first negative. Then we get d square minus 27d plus 50. Okay. Now, this is more convenient way. We need a product of 50 and sum of minus 27. So our trick numbers are 25 times 2 is 50, right? Right. So we'll take this 25 times 2. So d minus 25 times d minus 2. These are our factors, right? When you add 25 minus and minus 2, you get minus 27. When you multiply minus 25 with minus 2, you get 50, correct? So the equation for us is minus d minus 25 d minus 2, correct? Now the question is, how far from the bridge is the height? 5 meters, correct? So it could be, and this is 0 here, right? So it could be 0 only for d equals to 25, is it okay? Or d equals to 2, right? If you're looking from this side, it seems to be 2 meters. If you're looking from here, there could be another height, and that could be 25. Does it make sense to you? Yes, it does. Even from symmetry, it makes sense, correct? So the distance could be 25 meters or 2 meters from the left side, correct? So I hope there could be many problems where we'll be using factoring to solve applications, right? And to understand them better. The whole chapter on quadratics is based on this, correct? I hope you understand and appreciate it. Thank you.